All right, before we start writing on the foldable, let's talk about some vocabulary you need to understand as we go through here. And this should be vocabulary you already know. Let's say I give you an expression. What is the x called in this expression? Okay, give me another way to describe it. Whenever something has an exponent hooked to it, what is that called?
Coefficient.
Try again.
Power.
There is a power there, but this would be your power. What is the green circled called? Do you know? It starts with a B.
A B?
A B.
You said it starts with an E.
No, it's base. Oh.
This is your base, okay?
Do we have to draw this?
No, this is just a little bit before we get into all the properties that you understand what we're talking about. Whenever I say product, what am I talking about? What you get when you do what? Multiply. Product, we're talking about multiply. How about if I said quotient? What should you think? Division.
Where we writing this stuff at?
No, you don't have to write this just now. I just want to make sure you understand.
No, because I see a lot of other people writing.
All right, I think that's good. I think we can get into the properties. All right, so we're going to start. We'll roll through our foldable. I'm going to show you one at a time as we go through the properties, an example of each, show you what they do, and then we'll do some examples that pull all the properties together, okay? But on your homework, what you'll have to do is you'll have to simplify the expressions, but you'll have to tell which property you use as you go, so you're going to need this. Okay? It's not so much the point that you memorize the names of the properties, but that you know what's valid and what's not. And that's where this is going to help you. All right. What's the first one say?
Property.
Start at the top. Start at the
Power
top.
of the product.
Which one you got on the top?
So,
All right, so you're going to open the first flap, okay?
Yes.
So we're on power of a product, right?
Yes.
Okay. And beside power of a product, printed on your foldable, you see...
Parentheses A, B, plus parentheses M. What?
Okay? Now think about what this is saying. Product means to multiply. So I'm taking the power, which is the M, of something being multiplied, okay?
Yes.
Now, as long as you are multiplying inside these parentheses, it does not work if you are adding or subtracting, only when you're multiplying here. Then this exponent can distribute to both.
Repeat it, or would you just put them together?
You distribute it. The bases are different, so you want to keep them separate. Okay?
Explain that one more time.
All right.
Explain that one more time.
Open up the first flap and write it at the top there. Yep. So that whenever you want to know what is the product of a power, you can open right there and look right above it. Okay? Let's do it with some, and maybe you want to write in there, let's say when multiplying in parentheses.
So when it's an exponent, you don't multiply the numbers in the parentheses first and then do the exponent.
Yes, if they're numbers, but you're going to have variables in here this time.
So you have like an X in there.
Or, I mean, you could distribute first. It doesn't matter which one you do first. When multiplying in parentheses, you can distribute the exponent. You have to distribute to simplify. When y'all get that copied, I'll show you an example. And I'll put some numbers in there.
Hold on.
Wait, shh, shh, shh. The power, yeah, you look, guys. Understand inside these parentheses, this is two different things. So the exponent is going to go to both of them, okay? It's going to go to the 2 and the x.
Okay. Oh.
And it doesn't matter how many things you have in parentheses, you still distribute. Yep, you still use that same property. Let's say I had 3x, y to the second. For each one, absolutely, that's right. Well, it goes to the 2, so 3, 2, x 2.
Wait, where'd you get the 3 from?
These are 2 separate examples. If I had 3 pieces in there, it doesn't matter how many pieces are in there. If you're multiplying inside. Yep.
Unless they're real numbers, right?
Even real numbers.
I mean, like if you had 2 and 3 in there, you multiply the first, get 6, and then do the exponent.
No, you can.
You could,
No,
or you could take it to the 2 and to the 3.
no, you can't.
Either
Why
way.
not?
Here's the deal. Let me tell you about properties of exponents. Here's where properties of exponents get a little sticky. There's not an order of operations for properties of exponents like there are when we're doing other things. As long as your properties are valid each time, there's not a specific order in which you have to do them.
They'll always
No,
equal
not in
the
this.
same thing.
That's when we get into the addition and subtraction and stuff. Okay, now, don't write this on there, but I do want to show you this because this is where students always get mixed up. Yeah, Tyler.
Solve it past that point.
You can leave it like that. If you want to change it to 9x squared, y squared, you can. You don't have to.
So you got 2 and 3 in there.
Right now, I'm just worried about the
Hold on.
properties. Okay.
So if you got 2 and 3 in there, you could do both. Like you could do 6 squared.
I know what you're saying. You're
You
saying,
could do, not done. Or you could do 2 squared, which is 4.
We still a
and then
power
have
of a
9,
property.
and then times them.
and you'll get the same
That would
thing.
be 6 squared.
Do it both ways and watch. 2 squared times 3 squared.
But you just said you couldn't. But what does that equal?
Right? Now, what if I did 2 times 3 first?
6 squared.
But I thought you
So
said
that
we
would be
couldn't do that.
36.
No, you can.
If it's real
If they're,
numbers.
but see, if they're real numbers, if it's variables, you can't really combine those first. Okay? All right. Don't write this on your foldable, but I feel like I must show you this.
Boy, I ain't got the other one down, man.
All right, this is the one that I told you don't write, but I really need to show you this. The difference in this and what we've been doing is it's not a product, okay? There's a plus. You never, never, never
Add them.
distribute when you're adding in parentheses or subtracting, okay? You can never, well, you can't add those. We talked about this. When you see an exponent on a binomial like that, like 2 pieces being added together, that tells me,
You have to do the parentheses first.
and this is where we have to multiply it out
Would.
and distribute. Yes, ma'am.
multiply, don't add.
Right. All right. Now that's not a property of exponent, but I don't want you to get it confused with the power of a product, okay? Power of a product means you're multiplying, that you're adding, which is a sum.
Foil?
So
Yes.
if you add them, then you gotta put them like that.
You can't add x and 2 though.
You want us to write that down?
All right.
Huh?
No, don't write that on your foldable.
Okay.
All right, let's do property number 2. Power of a power. I hope you've seen some of these properties before.
Nope.
All right, so your example is a to the m to the n. So I've got a base of a that's raised to the m power, but then it's also raised to the nth power. So it's a power raised up to another power. What do you think you do?
Distribute the power.
Well, you can't really distribute,
the
but
parentheses and then the power.
let's say it's x to the second to the third.
You do x to the second, and so you would get like x times x, and then you do the power. Is that close?
Okay, you could, but let's think even simpler than that. That what we can do. Close. You multiply them. You multiply them. Who? I'm sorry, I didn't hear.
Miss
It would
McGee.
just be N, M, N,
That's what I thought.
A, M, N.
What I said.
I'm sorry.
That was the first thing I said.
Okay? So sometimes it's a little bit more difficult for you to see with variables, so I like to show you with a numeric example also. So if I had a base of x, this is an example by the way.
This is the easiest one so far.
This is the easiest one. Raised to the fifth, what does that become? X 15.
Wait, hold up.
You just solve it.
Okay.
Yeah, I'm trying to take notes.
All right. Shh. Power of a quotient. A lot of times, multiplication and division go hand in hand, and we've already talked about quotient indicates division. So your example on your foldable looks like this.
A over B.
Okay.
So you're gonna solve it, what's in the parentheses, then do it, or you're gonna distribute into both.
Exactly. As long as you're dividing. So we said earlier as long as you were multiplying. So now it's if you're multiplying or dividing. It just can't be addition and subtraction. You can distribute.
So if there's a variable, you have to distribute and leave it out to the side. And if there's not a variable, you solve it into what's in the parentheses.
Or you can distribute it even if it's a number inside. That's the one like Gil was asking where it came out to be 36, 6 to the second.
Oh, you just went to another one? And did you skip?
No.
We're not gonna do it. All right,
Did you get yours in the wrong order?
No, I did.
The question seems to be what if there's numbers in there instead of variables, right? So what if this was 5 over x to the third?
Then you're gonna distribute it.
It's still going to distribute.
5/3 over x to the third.
Yes, you could change it to 125 if you wanted to, or you could leave it as 5 cubed. That's up to you. What if it was,
6 and 3.
do something that doesn't reduce.
Hold on.
6
Well,
is 9.
11 and 9.
Wait, so you're not gonna finish it?
Finish it how?
Like, you're not,
Solve it. Like,
Yeah.
you like solve the rest
solve the
of it.
top.
You can leave it like that. That is simplified.
Oh, you,
If you want to change it to 125, you can. You don't have to.
distribute.
It still equals.
I'm still going to distribute. It's still going to be,
But if you get 6 and 3, you're gonna solve it and distribute.
yes, if you want to. Like if it was 6 over 3, you would change it to 2 and then do the exponent.
oh, yeah, so you don't have to actually do it, you just have to.
Right.
Do it, I guess.
Yeah.
It's still a rate if you have the exponent.
If you change it to 8 over, what is that, 216? That's not wrong. That's okay. If you change this one, this pen never wants to work. If you change the 512, 125,
Hold on there. Why don't you ever use the one I made? No, it's not either. So we're going to games this weekend, right? So we're going to games this weekend?
product means what?
Multiplication.
Multiply. Now we've done power of product. Now we're doing product of powers. So there's a trick to this one.
You just multiply. You just solve. Right?
Here's
this
the
was like
key.
the first one we
It's
did.
no, the first one we did looks like
You could multiply.
No, like it looks
So
like
if
the
you
first one when we get the form. Cause it'll be like 2. It'll be like 2 to the 5th times x to the 5th. And this one's already set up like that, kind of.
kind of. All right. Shh. Here's the key to this one, and you need to write this somewhere big so you see that the only time this works is when the bases are the same. Okay? Notice here my bases are the same. What are the bases here? A. So if you're multiplying and you have the same base, then guess what you can do with those exponents? Boom. How do you put them together?
Hold up, wait a minute. This may be-
You just add.
I know it's gonna get it eventually, if I just said add every time.
So
Somebody said
second
this was
week's
the
gonna be
easy.
harder or easier than the first?
Why is that not 2A?
I wanna hear.
Because 2a would be a plus a. Those have an exponent of 1, and you add them the coefficients. These we're talking about exponents, and we're multiplying, okay? So when we multiply, we add exponents. This is why when we were distributing through and we had x times x,
This is stupid.
So we're only gonna
we got x squared.
we got 8 weeks of teaching, right? And then we're gonna have 1 week where we.
Gil, worry about the lesson right now. Because the bases are the same, I add the exponents, okay? If I'm multiplying same base, I add the
What
exponents.
about
Then you cannot. So if I had x to the 5th times y squared times x to the 3rd,
You can only do 2.
I can only do the x's together there, which would be x to the what? 8, y to the 2nd. I can't do anything else with that because the base is not the same.
what about if there's only 2 and it was X to the Y?
You would leave
Just
it?
leave it?
Oh my God.
It's already simplified at that point.
Wow, amazing.
How'd you do it?
Because you can buy my car.
Thinking cap on for this one. Here's the one thing you need to remember. Never, 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 when you are simplifying, never, when? Never leave a negative exponent. Then it's not simplified. The whole point of this is simplification of expressions. So never, ever, ever leave a negative exponent. So, your next question may be, well, what do I do with it? If I happen to get a negative exponent, what do I do with that negative exponent?
Never leave a negative exponent.
Change your sign to change
You're going to change the sign to positive. I think the battery must be dead on this.
The battery in that?
Yeah, it has 2 batteries.
Oh, it's
What
that's
kind?
a lot.
Those little
Is it
little metal
triple
ones.
A?
The ones really.
If you see a negative exponent, change it to positive. And move it. Move it. What do you think that means? Move it where?
Well,
Do you agree everything can be written as a fraction?
maybe.
Sure.
Yeah.
Put it over 1. When you move it, if it's in the top and it's negative, you're going to change it to positive and move it to the bottom.
Oh my God.
What do you think you do if it starts out negative in the bottom?
Change it to the top.
Move it to the top.
Wait, so change to positive and move to the bottom. Right?
Correct. Or if it's in the bottom initially, you would change it to positive and move to the top.
Will it ever be like a negative number, like the actual number?
It could. The number in front wouldn't. That doesn't. No.
well, how are we solving it? That we wouldn't solve it.
We're not solving right now. We're just simplifying and breaking things down.
All right, this next has got to be zero.
No, wait. Let me show you another example with this one.
Thing that I don't like, it's not okay.
What if
I got this one.
all right, remember, only the one that's got the negative hook to it moves, okay?
You take a Y with it?
Yes, the base has to go with it, but only the base.
Is that 2 or 7?
That's a z to the negative 5.
You just
See?
Z,
you just switch y. You just switch y negative 2 and z negative 5. Just switch them two.
this one's negative, negative's bad, and it moves, right? So now I've got x cubed over, the z negative 5 is still there, the y moved down and became positive, right? But I still have another negative,
So move it to the top. You just switch it.
so this one
I
is
just
going to
said that.
become positive. I know, but I wanted to show you step by step. and move up to the top. Now it's simplified. Let me caution you on what students always want to do. Also, one more example on this one, and we're going to move to the next one. If you had 2x to the negative 3, what has the negative exponent hooked to it? The x. Not the 2. This is 2 times. 2 is a whole other base in and of itself. The 2, I'm going to put this over 1. The 2 is going to stay up top. It doesn't have a negative exponent. The x is the only thing that has a negative exponent, and it becomes positive. Does that make sense?
I don't like it, but it makes
All right, guys, I see several computers out. Y'all need to put those away.
Yeah.
Oops.
Guess what?
I'll pause. This is, y'all keep talking about, oh, that one's easy. The problem, for some reason, whenever students see all 7 properties, none of them are hard on their own. It's when we start putting them together.
Okay.
But this, in my opinion, is the easiest property. As long as the base is not 0 itself, okay? Anything raised to the 0 power, take out your calculator and do something raised to the 0 power, see what happens.
Zero.
Is it 0? It's 1.
Doesn't matter how it goes.
Okay. 5 to the 0, 1. Negative 265,000 to the 0 power.
Why is that?
Why haven't you ever gave us this before?
We haven't done exponents before. It's 1 because exponents
Oh my
are.
gosh, Miss Wiggy. Later in this year, like earlier in
Last one.
Yay.
Quotient of powers. Quotient means divide. Again, the key to this one, they must have the same base. It does not work if the bases are not the same. Now think about this a minute, because this one looks a lot like another one we've done.
Yeah.
We did product of powers, right? A to the m times a to the n. And if the bases were the same, what did we do with the exponents?
Added.
Added. So the opposite of multiplication is? The opposite of multiplication is division. So that's why we are subtracting, like y'all said, as long as the bases are the same.
How would we know? Like, what if you give us a list of problems, and what if they're set up the same?
Only the same bases can you do it. So again, if I had x to the 5th,
Well, I mean,
y.
like, how would we know one's, like, how do we know one's product of a power and the other's quotient of a power?
Well, if you're dividing, that's quotient of a power, and if you're multiplying, then that's product
I mean,
of a
like,
power.
if you give us a list and it's the problems listed in it, like, it gives us the problems, and how would we know if, like, one's the product and one's the quotient?
Are you trying to say power?
The other, it's just like a
One is a fraction, the other one is in parentheses.
So anything, let me say this, maybe this will
When
happen.
you
On your
divide them,
test,
is this
you're
correct?
not, hold on.
When you
On
divide
your
them,
test,
minus
hold
that
on.
exponent.
Yes. On your test, you won't have to list the name of each property, okay? But on your homework, you do to get you used to naming them. So on your homework, you'll be able to use your foldable so you can see which one goes with what. But on your test, as long as you remember the properties themselves, you'll be fine. If that helps. Now, Gil, yes, please.
I
What?
asked my question, you answered.
Okay. These have the same base, yes? So these are the ones that I subtract the exponents on. So 5 minus 3 is 2. So now I'm done with those. And then y to the second. We've already established that I can't combine those because the bases are not the same. So, let's work through some examples.
What did you say? Okay. Wait, so we're not doing that part?
5 minus 3. 5 minus 3. All right, let's do So here are the directions for a problem like this. We do have homework on this.
So we're not doing anything, it's just things that.
Simplify the expression and tell which property you used as you go. So we only want one property at a time. This is not from the homework. This is just an example. I don't have, that's not the homework for tonight. I haven't put it up there yet because I don't want you working on it yet because I want you to stay with us on our notes. Okay. The first thing that I see in parentheses is that the bases are not the same. Do you agree?
Yes.
So can I do anything inside the parentheses first? No. What do you see that I could do?
You have to do
Exponent.
the 2 times 5.
You're actually doing two properties in one. You're not wrong, but first thing I want to do is take this to both. Yes?
Yes.
So whenever I do that property, now remember this is 2 to the 5th to the 2nd. What is that called? What is the name of the property I just used? Power of a product.
Now you just, that's it. So you don't want to make it two.
You don't have to. Well, yeah, you're going to keep simplifying it, but you don't have to make this 16. No.
So you don't want to make it two.
Yeah, we're going to do that next. But I want you to do it a step at a time. One property at a time. So several of you are wanting to do this now. What do you do when you have a power raised to another power?
Of course, you add slash multiply.
You multiply. That property is called what? Power
Power of power.
Now you
Of
do
a
the same
power.
thing, this one, right? So you have negative 8 to the
Now
12.
we do product of the power.
You don't
Well,
do
can
that?
you do product of a power here? No, they don't have the same base. Absolutely. So I stop there. It's simplified. So that's it.
So it's just power of the product?
Yeah, well, it's two properties. It's
Oh,
two
okay,
properties.
So
Okay.
basically, if we work that bottom one out, it'd be the same one as the top one.
Yes.
So why wouldn't we just answer the top one?
Because you're not looking for an answer, you're looking for a simplified form. For example.
That makes sense.
What
I mean,
if the
actually,
numbers
I
weren't
don't
there?
understand why we would do that. I'm sure we have to.
It's something we have to know because the government says we have to know it.
I feel like this is different in every state.
What property you see first here? Guilt?
That's it.
That's not why I was calling your name, Guilt.
What?
Now,
That's for 5.
what property do you see first? And there's no right or wrong as long as it's a valid property. The negative exponent. That would probably be what catches my eye first. What do you do with a negative exponent?
Flip it.
Okay? So this becomes, I gotta hold its place with a 1 because there's not anything else there. R2S3.
So you do drive the base with the exponent. Okay.
Yes. That property is called negative exponent.
Wait, I got a question.
Okay.
Okay, so if you've got like 3
Mm-hmm.
to -2, and so you would have the 1 up top and on the bottom the exponent.
Yes. You always, if you take everything away from either the top or the bottom, you hold its place with a 1.
I was just making sure that the 3 would go on the bottom.
No. Yeah. What do you do now?
The exponents.
The exponent, top and bottom. I can take it here, I can take it here.
What would be this little thingy thing?
The name?
However,
The little
quotation.
thing that it goes down with. Is it a 1?
What you mean?
Cause like you know how you have 1 -3 right there when you 1 -2 at the bottom?
Well, no, it's going to be the R2S3, but it's going to be a -3 there. Okay? I told you when we start putting them together is when it starts causing confusion.
Yeah, when we were doing it, just writing the notes in the room.
And now we're adding.
What is that called? When you take an exponent to the top and the bottom, what is it called?
It's the
That's the quotient of the power.
Quotient of a power.
Is that, is we're gone. No, we're not.
Nope.
We just go do
What else can we do? You're only done when you can't do any more properties. Product of a power, which means because I'm multiplying here, I can distribute again. Now 1 to the negative third is just what? 1. What is 1 to the negative 3? 1 times anything, any number of times is still going to be 1. All right, so I'm going to distribute this through.
Oh, and then, so it's going to be -6, r -6, and then r -9.
Now you did 2 properties there in 1.
Maybe that's the quick way.
What 2 that's fine, but list them both, okay? What 2 properties did you just do?
Power of a power.
Power of a power, but before you did power of a power, you did what? Power of a product lets you distribute the exponent.
What did you, like, what were you doing?
I'll show you how I would have done this from the beginning. And then you did power of a power. There's only one thing left I can do here. Move them
I
up.
have one question. So at the start of the problem, it was r -2.
Mm-hmm.
Wait, what happens if they do the top one?
You
1 to the negative 3 is just 1.
I thought you had to take it down too.
Well, you could, but it's still going to be 1. If you take this down and make this 1 positive 3, 1 to the third is still 1. You'd still hold its place at the top with a 1.
I think the letter is
All right, I got r to the 6th, s to the 9th, and that's a negative exponent over 1 or just on its own, yes. Now, somebody said, what would you have done if you were doing this problem? How would I have worked it? Because I've told you there's not a right or a wrong way. As long as you're using valid properties each and every time, there's not a right or a wrong way. If I were doing this one, I would have probably started with distributing this exponent to both, which would have been r to the 6th over s to the negative 9. And that's 2 properties again. That's quotient of a power and power of a power.
So when you flip it, your answer would be at r6, s not positive, non-negative.
Which is, and I'm done. It depends, and I want you to see, and I never tell you what to do because I want you to see that even though you might do it a different way, it's not wrong. So I listen to y'all with what you want to do as long as it's a valid property each time, which is why I want you to write the property so you know you're using a real property each
So we
time.
can distribute every time.
As long as there's no plus or minus in there.
So every time it's distributed.
Is there ever going to be a plus or minus in there?
Not tonight.
Exactly. So
Yeah.
is there
On your test, yes. So I don't want you to, you know what I'm
the
saying?
rule of rest out?
Right.
Yeah. Mr. Gee, there's something under. Was there something under?
Where did this
Sorry. Just a 1. Just a 1.
No, I mean like.
No, ask, Ariel. Go ahead. Talking about the very last one.
Yeah. Thank you.
You're welcome. I want everyone to hear that question. What if there's not a property to use? If you can't find a property to use to apply, then you know that the expression's simplified and your job is done.
Are you gonna give us any variety simplified?
No, the 10 didn't tell you to simplify it. Nah.
Yeah, okay. Because that'd be very neat, and that was my first thought. And we're like, well, it's done at this point, but you're gonna give us that. That'd be.
Now, as I'm writing this, I've got 2 fractions that I'm multiplying together. Now tell me this. When you multiply fractions, if I have 2/3 times 1/2, what do?
You get the same dollar.
That's when you're adding or subtracting. Multiplying is even easier. Multiply straight across. Okay? Multiplying fractions is easy. It's straight across. So when you come to something like this, the very first thing that I do when I see it is I go, well, look, I'm just multiplying everywhere, so I'm going to make this y11 times 8 times z7 over 4 z third y7. So let's look for some properties that we can do. Do you see? Okay. I've heard a couple of you talk about the y's that are up top and in the bottom. What happens with those?
They,
You subtract. Now, when you subtract them, do you put what's left in the top or the bottom?
top.
Top. Always stay in the top when you subtract. Okay. All right. So 11 minus 7. 4. Everything else is still here. And on the bottom, I've got 4z to the third. That is power of a quotient or quotient of a power?
Wait, you forgot to put the multiply at the bottom.
Quotient of a power. Say again. Oh.
Yeah.
It's still the same thing.
Okay.
Yeah, I know it.
What else? All right. So this was quotient of a power.
So you do, when we do this, do we have to write down what it is?
You do. Yes. On your homework tonight, you will. Okay.
If I accidentally don't do
Just do it. Okay. What else do you see?
that.
I don't have any more room.
Okay. This is one of your homework problems, actually.
Oh, man.
I ran out.
So I'm going to subtract again, yes? So now I've got y4. I'm going to move this 8 in front, just because typically we put the number in front. 7 minus 3 is... Again, quotient of a power. You could divide 8 by 4. So if this is quotient of a power...
So this is power of a quotient, quotient, power of a quotient.
Power of a quotient starts with parentheses. Quotient of a power is whenever you have the same base and subtract.
the same thing. Wait.
Yes, they both have the same exponent. And now this is not an exponent property. This is just what you know about math. 8 divided by 4 is...
Are both your properties quotient of a power, or did you just write that twice?
Both of them are quotient of power.
Okay.
Tell me this and I'll be done, I promise. If I were subtracting, like let's say I subtracted these z's here, and whenever I subtracted, let's say these were flipped, and I had z to the third over z to the 7th.
Would it be negative?
It would be negative because 3 minus 7 is negative 4.
Good morning, Camden High
Stays up
School.
top though, and then it flips.
Please stand for the Pledge of Allegiance.